you will see equations that have more than one variable, but just do the same thing. Just apply the same action to both sides. All of the strategies we've discussed really work. So let's solve for h in this equation. S equals 2LW plus 2WH plus 2LH. Well, let's solve for h. That's the variable we want. So notice where h is. It appears one spot right there and a second spot right here. And so the thing that we said earlier of if the variable is written more than once, get all the terms with that variable on one side, get all the other terms on the other side, that still applies. This problem type, by the way, is a very common task in business calculus among other places. Um, in, this specific equation I took from my business calculus class that some of you will be taking after taking algebra, and this surface area issue comes up there. So get all the terms that have h on one side. How about we just choose the right side because both of the h's are already on the right side. And all the terms without h's will go on the other side, I guess the left side here. So let's subtract 2lw on both sides, and you have s minus 2lw equals 2wh plus 2lh. Now that all the terms that have h are on the right side and all the terms that don't have h are on the left side, well, we factor out an h. Right? This is the same deal we talked about just a moment ago with collecting like terms, and that's we shouldn't really ever call it collecting like terms. It's hiding that step, that's that key step of factoring out the variable that you need to. This is an important thing to think about in this format of factoring, because factoring, I think, helps clarify that where there used to be two written h's, when you factor out, you only write that thing once. That's good if we're trying to solve for this variable. We need to eventually have this variable written by itself only once on one side of the equation. So we went from writing h twice up here in the, right there and right there, to writing h only once. And now that we have stuff in parentheses times h, we just divide by what's in parentheses on both sides and we get a cancellation. So h is equal to s minus 2lw all over 2w plus 2l. Okay, let's try just clarifying some things by mentioning that here's a thing that sometimes people try to do for this problem. So I want to clarify what technically is going to be an answer. So if we subtracted 2LW and 2WH on both sides, we'd have just the 2LH on the right side. And if you divide both sides by 2L, it would look, here's the left side divided by 2L, this right side of 2LH divided by 2L. You can cancel the 2L on top and bottom. You just have H here, right? So some people might say, oh, look, I've solved for h, and this doesn't count as solving for h because there's still an h on the other side, right? There's an h still here. I just copied this work and highlighted where the h's are. So that doesn't count. So to really clarify, what does it mean to solve for h? You will have to ensure that your final answer has h on one side by itself and no h's on the other side. Just to say this with a different variable, when solving for c, your final answer should have a c on one side by itself and no c's on the other side. Let's take a look at another example from chemistry to solve for r here. This one's actually really nice. If it's helpful, you should rearrange the factors. So it's n times r times t. And we saw earlier that if you just have multiplications, you can shuffle the order since a times b is b times a. So if you'd like, you can rewrite the right side to be n times t times r if you like. And I'm going to divide both sides by nt. And so since these are factors, n and t are factors, you can cancel on top and bottom. I actually just really tried to clarify that nt is a factor on top and nt is a factor on bottom by rewriting the denominator as nt times 1. You don't have to write a step that looks like this. I'm just trying to really emphasize and connect it back to our fraction stuff. So then cancel the nt on top and bottom. You have r over 1, which of course you can just call r. So r ends up equaling pv over nt. Here's another one. Solve for s in as plus bs plus 8 equals cs plus d. Notice s is written 3 times in the equation. Once, twice, 3 times. So we need all the terms with s on one side and all the terms without s on the other side. By the way, if you divide both sides by c, that's a common approach that sometimes people try to take. You're allowed to divide by c on both sides. The issue is the c won't cancel. This c right there doesn't cancel with the c there because of the plus sign. The c in the numerator is actually not a factor. That's the issue. So you'd be stuck if you did this. If you divide both sides by c, you'd have this equation and nothing great would happen. You can't cancel the c's. So Part of the reason for this non-cancellation is you have terms up here instead of factors, right? So just to clarify the language, terms are separated by plus or minus signs. So in 3x plus 4y plus 8, for instance, there are three terms. 3x is a term, 4y is a term, 8 is a term. Factors are things that are separated by multiplication signs. So for instance, in 3 times j times k squared times m, we can say 3 is a factor because we can reshuffle this as 3 times the rest of the stuff. We can also say k squared is a factor because we could juggle the order around and say that this is k squared times the rest of this stuff there. Okay, so let's go back to this equation we were looking at. If dividing both sides by c is going to get us stuck, then since we have terms, right, with the plus signs, let's add and subtract terms on both sides with the goal of getting all the terms with s on one side and all the terms without s on the other side. So subtracting cs on both sides, then you'll have as plus bs, well, minus cs if you also subtract 8 on both sides. So going from here to here, two things happened. I subtracted cs on both sides, and I also subtracted 8 on both sides. Now notice that all the terms that have s are on the left side. All the terms that don't have s are on the right side. This is good, right? Because if all the terms that have s are on the left side, we designed it this way. If we kept, I did it 2 steps at once, but all the steps were taken to ensure that all terms with s are on the left side. And therefore, out of all 3 terms, you can factor out an s. So I would say don't even factor until you have all the terms that have the variable you want on one side first. And since literally all the terms have the variable on that side, you can factor out that variable from all the terms. And so we go from this problem situation of the variable s being written 3 times up here to s just being written once because we factored it out, right? That's the we don't want to have the variable written multiple times when we eventually solve for s. So factoring did this, but factoring would only work if all the terms with the variable were on one side. So that's why we sort of set up the bump set spike for this to make sure that all the terms have s on the left side here. And now that we factored, we have s times a thing. This kind of bigger thing in parentheses, we can divide both sides by that thing. And after a cancellation of that factor on top and bottom, we have s is equal to d minus 8 over a plus b minus c. Okay, again, just to comment earlier, we were stuck if you divided both sides by c in the original equation, on the right side you'd have cs plus d over c, and you'd be stuck because c is not a factor in the numerator. So on the other hand, just to compare over here, we can cancel quantity a plus b minus c because that's a factor on top and bottom. On the bottom, even though it didn't write the times 1 this time, it's 1 times quantity a plus b minus c. So we can cancel the factor on top and bottom.